All right, section 4.5 is on linear automobile depreciation. The depreciate is to lose value over time. Appreciate is to increase in value over time. So typically you hear as soon as you drive your car off the lot, you've lost money. That is very typical of cars. The older they are, the more miles you get on them, the more they depreciate. So question number 1, it says, Delia purchased a car for $25,350. This make and model straight line depreciates to 0 after 13 years. Identify the coordinates of the x and y intercepts for the depreciation value of the equation. Okay, so if you remember, we have x and y coordinates. Okay, the coordinate that goes left to right are your x values, and vertically up and down are your y values. Okay. So your value starts at 0 and goes all the way up to what she bought the car for at $25,350. That's your value, and your y value. And your x value is your time from 0 years when she bought the car all the way to 13 years when the value of the car is 0. So your x value is your time. Okay. So where the line crosses or hits the y-axis, which is your up and down axis, that is your y-intercept. Okay, so that is 0, 25,350. That is your y-intercept. And your x-intercept is where the graph crosses the x-axis, and that is 13, 0. So that is your x-intercept. Okay, so x-intercept is on the x-axis, y-intercept is on the y-axis. Part B, it says determine the slope of the depreciation equation. Remember, the slope equation is y2 minus y1 over x2 minus x1, and these x and y values come from your point. Your first part of your point is your x value, the second part of your point is your y value. Okay, so you notice here we have our 2 points up at part A, so we'll call this x1 y1 and x2 y2. Okay, so it doesn't matter what x1 is as long as the x1 and the y1 are together and the x2 and the y2 are together. So just take those numbers from the points in part A and plug them into your formula. This is your slope formula right here. All right, plug them right in. So 0 minus 25,350 and 13 minus 0. That gives you negative 1,950 over 1. Okay, once you reduce. Okay. Once you reduce, so your slope is going to be negative 1,950. Okay. All right. Part C, write the straight line depreciation equation that models the situation. So remember, that's your slope-intercept formula. That y equals mx plus b. M is your slope. Okay. And b is your y-intercept. Okay, so if you remember, our y-intercept was up here on the graph. It's where it crossed the y-axis. That value was 25,350. So that goes right here. Your slope we just found in part B, okay, was negative 1950. That goes right here in front of your x value. Remember, our x value was time, and our y value was our car value. Okay, so I just replaced the y and the x with the actual words so you can understand where they're coming from. So that is your equation. Number 2 says reference page 247, which is off to the right-hand side here. All right, question number 4. It says examine the straight line depreciation graph for the car. At what price was the car purchased? Okay, so in order to figure out what these missing values are, you just got to count how many jumps you have. So your jumps come into play right here. So 1, 2, 3, 4. You have 4 jumps, all right, to get to that one. And 1 more to get to the top number. So 5 jumps in total, okay? Take your 35,000, divide it by 5, so each jump is 7,000. So I just filled those numbers in for you. And do the same thing here. How many jumps? 1, 2, 3, 4, 5, 6, 7, 8. 8 total jumps all the way up to 16. So 16 divided by 8 gives you 2. So each jump was 2. Okay? So here is your time, your x, and your y is your value, your car value. So at 0 time, so right before you buy the car, all right, your car value was $28,000. So part A, what was the car purchased at? That would be $28,000. How many years does it take the car to totally depreciate? So you can notice the line goes down right here. The line goes down. So as it goes down, the value of the car gets lower as time goes on. So as you go down, that graph hits right here at 10. So 10 years, the car is worth nothing. Part C, write the equation of the straight line depreciation graph shown. Well, you got to find your slope. Okay, so your slope is, it goes down $28,000 in 10 years. All right, so you do negative 28,000. Okay, it goes down 28,000 and it took 10 years to go to 0. So you divide those two numbers and that gives you a slope of, negative 2,800. All right, now take it and plug it into your slope-intercept formula. Okay, so y equals mx plus b. So your value equals, all right, negative 2,800 times time. Okay, this should be negative 20. It kind of got separated a little bit. Negative 2,800 times time plus the y-intercept. If you look over here on your graph, the y-intercept is right here. Where does that graph, that line, hit the y-axis? Right at 28,000. All right, so that's a little bit of review of math 1, 2, and 3 stuff that you've covered in every one of those lessons before. So slope and y-intercept equations. Okay? All right, question number 3. The straight line depreciation equation for a motorcycle is y equals negative 2150x plus 17,200. What is the original price of the motorcycle? The original price of these in these equations is always your y-intercept, which is right here. The original price was 17,200. Okay, it's always the y-intercept, the original price, because the time is 0. When x is 0, that's when your original price is kicking in. How much value does the motorcycle lose per year? That's your slope. So if you look at your slope right here in the box, negative 2,150, that is how much it loses per year, $2,150. How many years will it take for the motorcycle to totally depreciate? Okay, that's where you take your equation and you plug in 0 for your value. Your y is your value, so plug in 0 for your y and then solve the equation for x. So you're going to subtract 17,200 on both sides and then divide by negative 2,150, solving a basic two-step equation. X will equal 8 years. Question number 4. The straight line depreciation for a car is y equals negative 2680x plus 26,800. The car, how much will the car be worth after 48 months? Well, our time was in years, so we got to first convert months to years. So 48 months equals 4 years. Okay, we know that. 48 months equals 4 years. So you're going to take your 4 years and you're going to plug it in for your time or your x value. All right. So negative 2680 times 4 instead of times x plus 26,800 gives you a value of 16,080. And then after 75 months, well, 75 doesn't work out nicely, so we're going to leave it as a fraction, 75 over 12. 12 months in a year, so 75 over 12 is going to be our fraction. So that goes in for x right here. Okay, plug that in for x. So negative 2680 times the fraction 75 over 12 plus 2680 or 26,800 gives you a value of 10,050. Number 5. A car was originally worth $34,450. It takes 13 years for this car to totally depreciate. What is the straight line depreciation equation for this situation? Okay, so we know that our y-intercept, our original value, is $34,450. That is our original value right here. So we know that's going to be our y-intercept. That's how much we bought the car for. Now we need to figure out our slope. Well, you take your original price of $34,450, divide it by how many years it takes to depreciate, which is 13. That gives you a slope of 2650. We know our slope, depreciate means lower, so we know we're going to have a negative in front because we're going down every year. So your equation would be value, or y, equals negative 2650 times time, or the X value, plus 34,450. How long will it take for the car to be worth half of its value? So half of its 34,450 divided by 2 for half gives you 17,225. So we're going to try to figure out, that's our new value, so that goes in for your value spot, equals negative 2650 times time. We're going to solve for time, or solve for our X value. Remember, X was our time. So again, solving a two-step equation. You're going to subtract the 34,450 on both sides, and then you're going to divide by negative 2650 on both sides, and that'll give you your X value, or your time. Your time would be 6.5 years. And part C, how long will it take for the car to be worth $10,000? So your value, you're going to plug in 10,000 for your value, and you're going to solve for time again. So again, subtract your 34,450 on both sides, and then divide by negative 2650 on both sides, and you'll be able to solve for your time, or your X, which is 9.2 years. And that is it for section 4.5.